Hello, my name is Jacob Ditkoff, and I'm going to be talking about my project for Internet of Things, which is on guided parking structures. So I'll first start off by talking about my project and the motivation behind it. Then I'll go on to talk about my project's design, both the software implementation and the hardware implementation. Next, I'll show a demonstration of my project. Finally, I'll conclude and talk about what can be done with my project in the future. So for some background, for anyone who's driven before, I'm sure that you know the stress that comes along with driving through a massive packed parking lot trying to find a spot. It can often feel like a huge waste of time with the potential for very little reward. A full parking lot can mean the difference between being early or on time and being very late to a plan. So my proposal is to create a low-cost and modular design for a guided parking structure which can be easily integrated into both new and already existing parking lots. This will allow for parking structures to be more easily monitored and populated, and will remove the free-for-all and stressful feelings that come along with trying to find a parking spot. So to implement my proposal, I'm using two boards, an Arduino Uno and an Atmega 2550 board. Along with this, I'm using an HC SR04 ultrasonic sensors, LEDs, and a breadboard with jumper cables to wire the project together. I had originally planned on using weight sensors, as seen in the picture, but three of my weight sensors broke at a very unfortunate time, requiring me to replace them with my ultrasonic sensors. Fortunately, the way that I've written my code allows for me to swap out either type of sensor with very little modification of the program. So here is the control flow diagram, which shows the general structure of my software. We start by monitoring the entrance. When a vehicle approaches, they either press a button or they're detected by an ultrasonic sensor. Next, a signal is sent to the Atmega 2560 board, which then checks to see if any spots are available. This is done by pulling the signals sent from the Arduino Uno, which is constantly cycling between the different ultrasonic sensors to see if any of them do not detect a vehicle. If any spot does not detect a vehicle, then the Atmega 2560 will pick a spot and illuminate a series of LEDs to that spot, which also has an LED associated with it. The parking spot is then populated by the vehicle, and the system is ready to accept another one. If no spots are available, then we can display that there are no available spots at the entrance of the parking lot, thus reducing the amount of wasted time having to circle around a parking lot in the hopes that there might be a spot. I'll now walk through the way this is implemented in software. So to start, I'm using Arduino's IDE, which allows for easy uploading and monitoring of Arduino compatible boards. I'm also using the timer library, as seen here, which is necessary for measuring pulses from the ultrasonic sensors. From the top, I've declared all the pins I'll be using on my Mega board, as well as some constants which are needed for the ultrasonic sensors, and some convenience constants, if anyone wants to build upon my code in the future. So next I have my arrays, which monitor the actual spots in the parking lot, and then monitor a representation of the spots in the parking lot, and then both my parking lot LEDs and the guidance LEDs. So next I've initialized all of my sensors as well as my LEDs, and I've initialized the parking lot representation to be fully empty. So inside of my loop here, which is akin to the main function in C and C++, I have code which states that if the button is pressed, then find an available spot. And again, this can be very easily swapped out or modified with using an ultrasonic sensor. And I've even left the code in there as an example of how that can be done. So if we go down to the code for finding an available spot, we can first see that we'll check if any spots are available. So if there are any available spots, then we grab the spot, print out which spot is taken, and then turn on the guidance LEDs as well as the spots in LED. The guidance lights will stay on until the ultrasonic sensor monitoring the designated spot detects that the car pulls in front of it. So next we'll go to the Uno code. The Uno code is as follows. So the Uno is constantly polling each sensor to see if any of them register an object. If any spot detects an object, it writes out to the Mega board so that it can tell which spots are populated and which spots are empty. So next, I'm going to show you a demo of my project in action. So for my demo, I'm going to walk through a couple common parking scenarios. This demo will be using 3 parking spots, as these are the number of ultrasonic sensors I have available to me. However,
This can easily be increased to as many parking spots that you might need. You're only really limited by the number of pins that you have on your board or the number of ultrasonic sensors that you have on hand. For a reference, I've drawn out the sample parking garage to show the layout. Each spot and each LED is referenced on both the reference page as well as underneath the breadboard, and it's all clearly laid out. So you see spot 1, spot 2, spot 3, spot 1, spot 2, spot 3. The guidance LEDs to those spots are written out here, and then the spots LEDs as well are also written out above. For the first scenario, we're going to go from an empty parking lot and fully populate it. So the first thing that happens is a driver will come up to the garage and press the button to enter. So when they press the button, you can see that the first thing that happens is spot 1 LED will turn on, as well as the guidance LED for spot 1 will start flickering. So when we populate spot 1, you can see that the guidance LED for it will turn off, but the spot LED will stay on. So the guidance LED turned on, and then when you pull into the spot, the guidance LED turns off, but the spot stays on. Similarly, a driver comes in and presses the button again, and then spot 2 LEDs will turn on, as well as the 2 guidance LEDs leading up to it. So when you populate that spot, you can see that the guidance LEDs will turn off, but spot 2's LED will stay on. Finally, the third driver will enter, and they will press the button as well, and then all 3 of the guidance LEDs will turn on, leading you to spot 3. Then, when you populate the spot, you can see that all 3 of the guidance LEDs turn off, but all 3 of the spots stay on. The next scenario will show what happens when all 3 of the spots are fully populated, but another driver tries to come in and enter the parking garage. So, as you can see on the monitor, all 3 of the spots are currently taken. However, if we try and press the button again, nothing will happen. So if you look on the monitor, it will say that there are no more available spots. Next, we'll remove the cars in any particular order and show that the corresponding spots have been turned off. When the corresponding spots turn off, that shows that also in the code, that spot is considered to be empty again. So if driver 2 decides to leave, you can see that spot 2 has turned off. If driver 3 then decides to leave, spot 3 will turn off. Finally, if spot 1 gets freed up, spot 1 will turn off. For the last scenario, we'll remove one car, but then have another car enter to fill in that spot. So if we remove spot 2 LED turns off. If we press the button again to show another car entering, spot 2's LED is the one that turns back on. And then when we place the car in its spot, the guidance LEDs turn off and spot 2 is populated again. If we do this for spot 1, spot 1's LED will turn off. And then if we press the button again, the spot for spot 1 turns on, as well as the guidance LED for spot 1 turns on. And then if we populate the spot, then the spot's LED will stay on, but the guidance LED will turn off. So this is just a basic demo to showcase some common scenarios that can occur in a guided parking structure. Again, this works for however many spots you hook it up to. You're just limited by the number of ultrasonic sensors that you might have on hand to connect to your board.
So what did I accomplish in this project? I was able to make a proof of concept of a design for an automated parking structure. It's both cheap and easy to integrate into parking lots that already exist and parking lots that are being built. The code I've created is easily modifiable and can be built upon to work in larger and more complex parking structures. I did run into one major issue, which was that I had originally intended to use weight sensors under each spot, but as I was finalizing my design, 3 of them failed, requiring me to use my ultrasonic sensors instead. Thankfully, the code I wrote was able to accommodate that change, and it can be switched back to weight sensors very easily with minimal changes to the code. In the future, some welcome additions to this project would be a higher quality weight sensor. With more reliable weight sensors, you can create a more complex parking algorithm that can do things like differentiate between the type of vehicle and have them park in different sections of a parking lot to ease the flow of vehicles throughout it. Finally, creating a phone or a web app which can check on available parking spots in a parking lot would be a welcome addition that would even further reduce the stress of finding a spot during a busy time. Thank you so much and have a great day.